Okay, Chapter 7, Problem 51. We have the center of mass of an empty 1,250 kilogram car. The center of mass of that car is 2.40 meters behind the front of the car. What we're supposed to do is figure out how far from the front of the car will the center of mass be once some people pile in. We've got two people that sit in the front seat, 2.8 meters behind the front, and three people that sit 3.9 meters behind the front. And we're supposed to assume that each person weighs 65 kilograms. So the picture here, very, very elaborate car. Look at that. That is a nice looking car. We have the total mass here, so I'm just going to do this quickly. We're going to draw something simpler that we can analyze. We've got 1,250 kilograms, and we're told where that center of mass is. Then we've got two people that sit in the front. We'll assume that they're basically in the same forward direction. So that's supposed to be two people. And then we've got three people here. And each of these people, each is 65 kilograms. Okay, let's draw a simplified picture because as beautiful as this is, we're going to need something nicer. So let's just represent everything in one dimension. So we've got our car. Okay, and what we'll have here is let's turn it the other way. Let's have the front be here at 0. That'll just make our life easier. So here's the front of the car. The rear is back there somewhere. What we're told is the center of mass of the car is 2.4 meters behind the front. So I'm orienting myself this way. I'm going to put this right here. This is center of mass of car, and this distance is 2.4. I'll put that here, 2.4 meters. Okay. Then we have two people that are seated 2.8 meters behind the front, and so I'll put this right here. The center of mass of those two people, two peeps, at 2.8 meters. This is, of course, not drawn to scale. And then there are three people at 3.9 meters behind the front, and so that's, let's say, somewhere over here. Okay. Center of mass of the three peeps at 3.9 meters. In fact, let's just kind of think about this in this way. Let's start. The center of mass of the car, that's going to be the thing that dominates because it is way more massive than any of the people or even the total mass of the people. Whatever we get, we should expect that the overall center of mass of this system should lie somewhere in between the extremes and probably pretty damn close to the center of mass of the car. So in case we get something that's way far off, then we'll know that we did something wrong. So conceptually, we've got center of mass. There's really only one equation to use there. I'm just going to write that down. So concept and equation, center of mass. We only have one dimension to worry about. The x position of the center of mass of the whole system involves the mass of the first object times the position of the first object, mass of the second object, position, third object, third position, etc. We only have three objects to worry about. You'll notice that I'm going to take the two people, since they're in the same location, I'm just going to consider them one object, and the three people as one separate object. Don't forget to divide by the total mass of the system, m tot. Okay, before we go and use this formula, let's make sure that we've got everything organized in our mind. What we're going to do is treat m1 as the mass of the car. That is 1,250 kilograms. m2 corresponds to the mass of that second object. That's the mass of the two people. 65 kilograms each, 130 kilograms if I did my math right. The three people in the back seat, that's 3 times 65. I'm going to look down just to make sure that I've got the answer written here. 195. That should be 130 plus 65. Okay, good. x1, x2, x3. We have those. I'll just kind of summarize them again. 2.4. 2.8, x3 is 3.9. And then m tot, of course, is the sum of those. Okay? So when you plug everything in, I'll skip the algebra for you. What you should find is the center of mass is equal to 2.62 meters. Where does that reside? Somewhere in between the center of mass of the car and the two people, but definitely much closer to the center of mass of the car than, let's say, the three people in the back seat, which is consistent with what we expect.